What are observables, how to subscribe to them, and whether we need to unsubscribe from them, and if so, when to do so. An observable enables subscribers of data streams to get push notifications from the producers of those streams. When and how to subscribe to an observable. The keyboard event could be converted to an observable and subscribed to by one or more subscribers. The event will fire away even if there are no subscribers, as the producer is outside the observable. We can use the from event function to convert the keyboard event to a source observable. Our source observable is now ready for subscription. To subscribe, we need to pass an observer object to the subscribe function of the observable. The observer signature includes three functions. Next handles the success path. Error handles the failure path. And complete finalizes the subscription. Now that we know what observables are, let's figure out when to subscribe to one. Imagine a fire hydrant to have an observable of type water stream. The fire hydrant will remain dormant till a fireman connects a fire hose to it. At that time, the fire hydrant is considered to have had its first subscriber. Let's write some code for our fire hydrant example. We first define our water stream types: lots of water, some water, and little water. Then we create our observable of type water stream. We now subscribe to the water source observable. Next handles the case where there is water stream in the fire hydrant. If water pressure is optimal, we can fight live fire. Otherwise, we might only be able to fill the tank for later use. Error handles the case where there is no water stream at all. Complete handles the end of subscription just before the fire hose is disconnected. When to unsubscribe from observables, you might ask. The answer is always. You need to turn unsubscribing from observables into muscle memory. Do it always. Just remember that every call to the subscribe function of an observable deserves a call to the unsubscribe function of the same observable as soon as you're done with that observable. Unsubscribing from an already unsubscribed observable has no effect. However, not unsubscribing when you're done with an observable can have a devastating effect on your application. Let's have a look at a real example. We're creating a crypto application in Angular. Customer use pay-as-you-go to search for crypto prices. The application has two-tier pricing. The fast API will take less than 1 second to return the search result. It is the more expensive option. The slow API will take more than 10 seconds to return the search result. It is the cheaper option. Clicking on a search tab will create a new component for that tab, and clicking away from a tab destroys the component of the last tab. Let's look at our crypto data model. We have two server types, fast and slow. We have the data transfer object as well as the application state, which includes the loading flag. Now that we have our model file, let's create an application-wide service which is responsible for making calls to both slow and fast servers, setting the application state as well as handling the loading flag. To demonstrate proper subscriptions and unsubscribing requirements, we create two distinct components, one for the fast search and one for the slow search. The fast component will take the user input, debounces the input for 300 milliseconds to ensure that we're not overwhelming the API server on each keystroke, and finally pass the crypto token name to the API and will display the token info it receives from the server on the page, and that includes the token price. The crypto information received from the API is contained within the component itself. However, the service will be responsible for tracking the loading flag. Let's check out our application in action. We click on the Fast tab to create the Fast component. We type BTC for Bitcoin and hit the Fast API server. The loading indicator is properly displayed during the request response window. The response comes back within a second and Bitcoin information is displayed on the page. Let's create the slow component. The slow component is identical to the Fast component with one exception. We send the search request to the slow server. The slow server will take more than 10 seconds to respond back. Let's take our new component for a spin. Click on the slow tab, type in BTC for Bitcoin. Our request will be sent to the slow server. A progress indicator will show during the request response window. The server will respond in 10 seconds or more, and the result will be displayed on the page within the slow component. Let us simulate a race condition using our fast and slow servers. Our slow server takes more than 10 seconds to respond. Our fast server takes less than 1 second to respond. What if we make a request at time t equal to 0 seconds to the slow server? Then at time equal 5 seconds, we make a request to the fast server. The fast server will respond at time equal to 6 seconds. The slow server will respond at time t equal 10 seconds. All right, let's click on the slow tab and send the request for BTC to the slow server. A progress indicator will show. That would indicate that we're awaiting a response from the slow server. Now let's go to the fast server and send a request for Ethereum. ETH. This time we're going to send it to the fast server. The progress indicator shall remain, and then within a second of that, the response will come back and we will display the information for Ethereum and the price for Ethereum. Please note that the progress indicator has disappeared. And let's see what happened under the hood. We clicked on the slow tab and sent a request to the server. Then we destroyed the slow component by clicking on the fast tab. We then send a request to the fast server and we received its response within a second and we displayed it on the page. 10 seconds later, the slow server responded and the response triggered some out of context execution. This is due to the fact that we did not unsubscribe from our search observable. So what is the status of our slow component? We know that it's destroyed, but it's still subscribed to. A memory leak, a slow performance, the outcome would be gradual performance degradation. Let's make the impact more profound by making the component trigger a shared state change within our application. This is to underline the importance of unsubscribing when a component is destroyed. Here we make a request for info on BTC to the slow server. A few seconds later, we change our mind and make a request for Ethereum, but this time through the fast server. The response from the fast server comes back and is written to the state and displayed on the page. However, the response from the slow server comes back soon after, and since we did not unsubscribe on destruction of the component changed the state and BTC info overwrote Ethereum, even though the last request was for Ethereum and not BTC. In this example, the slow component was destroyed, yet still subscribed. The issues would be memory leak, state corruption, and performance. Outcome could have devastating impact. As per Scott Galloway, during the holiday season, the shipping company was off by 1. and sent all the gifts ordered through his company to wrong addresses. His company went bankrupt due to a simple yet devastating software issue. Now, how to prevent it, you might ask? The answer is, again, always unsubscribe. Always unsubscribe. Turn it into a muscle memory. You have to always unsubscribe. A great way to automatically unsubscribe is using take until from RxJS. When the component is destroyed, the destroy hook will trigger a destroy event, and that will signal take until to unwrap and complete the subscription that comes after it. Let's have a look again. BTC request is sent to our slow server. A few seconds later, we change our mind and make a request for Ethereum, but this time to our fast server. The response comes back from our fast server. It is written to our state and it's displayed on the page. However, the outstanding response from the slow server comes back soon after. And since we did unsubscribe on destruction of the component, nothing happens, as our application state is not clobbered by a destroyed component. In conclusion, when in doubt, unsubscribe. Always unsubscribe. Turn it into muscle memory. If you're not sure, unsubscribe. Double unsubscribing has zero impact on your application. Not unsubscribing could be devastating to your application. When in doubt, unsubscribe. Don't forget to subscribe and share with others. Thank you.